Hello everybody, this is Thomas Ott for NeuralMarketTrends.com and welcome to a new video. Today I'm going to talk a little bit, or I'm going to do an introduction to driverless AI, just a short piece because there's multiple pieces of driverless AI from H2O that need to have their own specific video dedicated to them because it's quite a complex product and quite a powerful product. Now that said, I do currently work for H2O.ai. So a lot of what I say here will not necessarily reflect the views and opinions and all that legalese stuff of my employer. These are just my thoughts and so forth. For the most part, everything is generally aligned with H2O's vision and goals with driverless AI and their open source product suite. So that's kind of where I actually would like to begin this video before we dive into some introductory data loading, looking at the analysis of the data, and some exploratory data analysis for this particular video. The other videos I will plan to talk about actually how do you use driverless, how do you set your prediction columns, drop columns, different scoring mechanisms and so forth. Then perhaps we'll move into another video doing the actual machine learning interpretability as well as some of the auto documentation and so forth, right? All encompassed in that. But before we begin, I just want to show you actually two simple slides here to kind of show you where driverless AI fits into the H2O ecosystem, and as well as where does it fit into the data science journey as well too, or the data science flow. What you see here on the left, those three open source product, H2O, Sparkling Water, H2O for GPU, those are all completely open source. You can download them, you can use them, you don't even have to tell us that you're doing that, which is a really cool thing. This is an actual true open source part in the data science ecosystem. H2O algorithms were always designed to be very scalable. They were designed to be fast, accurate, run on big data, small data, and so forth. And what you get is some really powerful algorithms. I believe our open source GLM algorithm is the fastest in the world out there right now. Hopefully, knock on wood, that's not going to change by the time this video comes out or so. But it's always been meant to make the journey of a data scientist a lot easier by using these top-notch algorithms. That's what H2O was born. Part of the H2O ecosystem is as well the H2O Flow, which is a browser-based point-and-click type of thing, data science type of workbench. Now, out of all these open source tools as well as driverless AI as well, everything expects to have a training data set ready to go. So we don't really do a lot of ETL, the basic ETL type of stuff. We do like the data science ETL, which is the transformation, bucketing, binning, one-hot encoding, those type of data science transformations we definitely do. But, taking SQL data dumps and, rough munging everything or so, and that's kind of has to be done outside of driverless. As well as outside of our open source. Of course, we have R and Python bindings. You can do all that beforehand if you want to create your own frames or do your own SQL type of thing. But for the most part, all that heavy lifting is done outside of driverless and open source technology. So let's move over to where the left part or the right part of the screen here is. This is driverless AI. This is kind of was born out of our open source stuff. This is not just taking our open source products and slapping a fine GUI on top of it. This is actually enhancing it with more things that our open source doesn't have. Things that are on the cutting edge of our cutting edge in the data science machine learning world. Things like machine learning interpretability, simple things like even auto documentation. I mean, how many data scientists out there really love writing long documentations of the experiment and everything that they've done? Of course, they can definitely do it. But it's not something that they necessarily want to do, or at least it's my experience. We'd rather be building models than actually, writing everything down. So there's a lot of neat stuff that is in driverless AI that is definitely not in the open source, of course, right? And driverless AI is actually a closed source product. It's a commercial product. So you got open source on one side, and you have one product that's closed source, and really it can be up to you what you would like to use, right? So now, having set that stage here, let's talk a little bit about where does driverless AI fit into the data science workflow aspect of everything. And it sits over there in that gray box over on the right side there, right? So like we talked about that data integration, that basic ETL on the left there, that's not what we do. We expect a curated training data set ready to go. And while some people may say that's kind of, well, I kind of wish I can do it all, we're not really necessarily that focused on doing the ETL work. We're really focused on the algorithms and the data science and the machine learning part. So we take that expertise and we focus on that, right? Better to be a master at something than a jack of all trades and master of none, right? That's kind of how we look at things. Where we start the ETL, the transformation part, is right there in that very left part of the gray box. The one-hot encodings, the frequency encoding, binning, log normal transformations, all those different things, target mean encoding, all those different things that we need to manipulate the data so that certain algorithms can actually perform better, right? I'll give you a perfect example for feature generation, which is what Driverless AI does, feature engineering. The example I always like to give is if you have a column of, let's say house prices and a column of square foot areas for the house, you can quickly create a new feature dollars per square foot. And that allows the algorithms to make a better comparison, right, between each row or so forth. So we do the transformations, transforming the data, and we also do the feature engineering by some amazing amounts of, or some not amazing amounts, but some really detailed steps that we do, to either the target itself or to actually all the other features and so forth. So that's a highly iterative process. And this is where running on GPUs as well as CPUs really comes in handy, because all that calculation, that matrix types of calculations, all need to be done in something that is very powerful memory-wise. So that's where GPUs actually can accelerate your time to building models. I've seen running an experiment on CPU take 10 to 12 hours, where it's running on with a GPU enabled, a single GPU enabled, cut that down to half, and in some cases even more than half down time-wise. So if time, of course, is your main feature or main issue, then take a look at using harnessing GPUs with Driverless AI. So what else do we do, right? Not only do we do the data ETL, data science ETL stuff, we also do the feature engineering, which we'll talk about in another video, and then we also do the model building. This is where we do different model bake-offs, if you so will, where we try an XGBoost versus a GLM, or maybe we use TensorFlow for some NLP stuff, right? And we iterate over different models, we iterate over different algorithms, and we optimize them. We optimize them to whatever your performance metric is, log loss if you're doing imbalanced data sets, or area under the curve, or root mean squared error if you're doing some sort of regression type of problem. We optimize over those to get you the best performance vector that you can. And then at the very end, we present you with the model. And this is the cool part about it. This driverless AI still maintains the same heritage as the open source. Where in the open source, you were originally able to produce a POJO, which stands for a plain old Java object, or now a Mojo, which is a model-optimized Java object, and that presents you. That gives you all the code, gives you everything you can do. You can run that in a Java JVM, or in a Kubernetes container, or Docker, or whatever you like. It becomes very easy to productionalize, put on a Spark cluster, and so forth, or do whatever you like with it. With Driverless AI, we are actually amping this up a little bit. We're actually looking at doing Python scoring pipelines as well too. So we produce the wheel files. Everything is completely encapsulated. There are no other dependencies that you need to install to make this run. So not only do we do the Mojo export, we also now do the Python scoring pipeline. And rumor has it at some point there'll be other types of pipelines to be able to export in Driverless. And now the cool part about all this as well too, similar to the same old heritage that we had in the open source, is that we also provide you a Python client with Driverless AI, and an R client coming out shortly here, which will then allow you to use R and Python to push stuff right into Driverless without seeing it, just like what you've done by using the libraries in the open source as well too. So that's kind of where Driverless AI fits in the realm of your workflow, right? And And you really do get a big lift out of this, right? You can maybe make the argument and say, well, 80 to 90% of my time is ETL work, so why don't you just spend more time on that? Well, we actually give you more bang for the buck, and we actually speed up things, and we do the model building, model bake-offs, model optimization for could be thousands of models, thousands of iterations with different types of features, right? We found that the feature engineering part is really the key part in actually squeezing more performance out of your models, as well as the iteration and the optimization. Right, so that's where we focus, and then of course we add things like the autodoc, and we add things like machine learning interpretability, and a couple other little things, and wrap it all together. Right. So now, hopefully, you're completely interested in driverless AI now, and let's actually move over to driverless AI. Before I actually switch over screens, I'm going to talk a little bit about, I'm actually currently using Puddle, which is our fast POC type of environment. And this is typically done, in order to run it, you typically need a code to get started. So normally what we do is any type of prospects or customers that want to try it out, definitely reach out to us, our sales group. I think it's sales at H2O.ai to get a test code and run it yourself and so forth. So now let's switch over to that, and actually I'm going to, let's see here, I'm actually going to load up driverless AI, and you can see the very first thing that I did here is that it asked for my license, and for that you're definitely going to need to get a license from sales at H2O.ai to actually get this to run, as well as the credits. So you can't just go in here and spin up and use up our time here, per se, on Amazon. So let me just go over here and switch over and grab my license here, copy, and then I'm going to come over here and enter it, paste it, make sure it's all good, and hit save. Okay, good. So now driverless AI is activated. So now what? Now you're presented with the very, very first page, the datasets page. We can't do any modeling, of course, without data. Right? So a couple different things that we do is we allow you to load in data in very easy ways. We have multiple connectors to things like Snowflake, Minnow, HDFS, local files, and so forth. And for the most part, a lot of this stuff may be grayed out. I currently have only four types of ways to load data in, either from a local file system, or uploading a file, or Amazon S3 bucket, or Hadoop HDFS layer. But if you wanted to find out all the different various data connectors, I would suggest that you go over to the driverless AI documentation. And that's located at docs.h2o.ai. Just search for driverless AI. And you can come down over here and you could actually come over here and say enabling data connectors. And in here, really what this is going to do is it's going to tell you how you can actually do it from a Docker image, how you can do it from a native install like a tarball or a RPM or deb package, and so forth. And you can just read through that. And a lot of this is going to have to do with enabling these connectors in your config.toml file. Everything that driverless does here is based off of the config.toml file, and you can find that over here. You can find a sample one. And in here you can see a lot of different things are grayed out with hashtags and so forth. And if you can scroll through here, you can set things like your level of cardinality, what type of correlation values, if you want to drop everything at 70% or less or whatever it is. You can definitely do all those type of configurations here, as well as set up things like LDAP or Active Directory. Are you doing HTTPS? You're doing those type of things, as well as other type of connection methods as well, like OpenID and so forth. So all that information is located here in the config.toml file that is on docs.h2o.ai. So definitely check that out and so forth, right? So what we're going to do today is we're going to just come over here and we're going to upload a very simple file. And for my case, what I'm going to do is I'm just going to use, in this case, the diabetic data set. It's a hospital readmission type of data set. And all it is it's just really a bunch of, did people get readmitted in the hospital within the last 30 days or greater than 30 days and so forth. And it comes out, it's like a very, very small data set. It only has about 101,000 rows with about 50 columns, and it's about 29 megabytes. The next question that I'm going to get from everybody is, well, how big of a data file can we actually load up in here? It's been tested to 1 terabyte, but your hardware and all those things are definitely going to be going to give you different mileage. But for the most part, if you have a 1 gigabyte file, let's just say, you're going to need to have at least 4 gigabytes of available memory for driverless to actually churn through the data and actually build models. It's really a 4 times type of ratio. Data size times 4 is what you're going to have available for memory, whether CPU or GPU processing and so forth, just to process the data and build the model. So that's just a caveat. That's something to think about as you're loading in this type of data here. So the very first thing that what we can do is we can select this. And once we select this data set, we can do a couple different things. And we're going to just focus on details today, and we're going to focus on visualize today. We're going to definitely do a couple other things going forward. We may talk about the download, which is very simple. You can download the data again. We're going to talk about splitting in another video. And of course, we're definitely going to talk about prediction and as well as other things like the MLI and diagnostics and deployments and so forth. So Driverless AI is a very powerful tool. And this currently I'm showing you is version 1.7. This is an early release candidate type of thing, and which we're going to talk about a little bit later on. So let's look at the diabetic data set. Click on this and go to details. Details is just that. It is just a high-level overview of the data. It is looking at the name of the columns, the name of the features, what data type is it integer, is it string or real, what the counts are, what the median value is, max, min, standard deviation, frequency of data types and so forth, or frequency of unique values, and so forth, right? So this is all important high-level stuff that we need to look at. And of course, it'll give us like a little visual tag, what the distribution is, kind of like almost like a histogram here, what the distribution is of various categoricals, 75% Caucasian, roughly 20% African American, and the rest are all other, right, type of thing. Male to female ratios in this data set and so forth, right, as well as, things that might be missing and so forth, right? So which is all important information that we need to know to understand different things, right? So we can also come over here to look at the data set rows, right? And the data set rows is the tabular form of that. And sometimes this is very important to look at as well. I look at it in both ways. I look at it in high-level overview to get an understanding of what the data types are and what I might be up against. Did a string data load in correctly? Sometimes I have found when looking at large data sets, this becomes incredibly helpful. I was working on site with a client, and they specifically had, they said, a numerical column, and they pulled this out of a Hadoop cluster, and when we loaded it into Driverless, it came back saying it was a string. And we were going back and forth, and sure enough, they had a NaN, not a number, which that term was in there, which in their Hadoop cluster was recognized differently than it was in Driverless AI. And once we found that out and once we understood that, then we were able to correctly change the data or correctly shape the data and load it in, and everything worked. So the statistical overview is incredibly important for that. And I would highly recommend that before you do any type of model building in Driverless AI, definitely look at the details and definitely look at the data set overview here. Okay. So there's another part of this exploratory data analysis that we're going to go to next now, which builds off of this, but uses actually a little bit of machine learning in the background to figure out stuff, to figure out interesting relationships for you, the data scientist, to really look at, right? This is all exploratory data analysis. This is not an interactive drop this, remove this. We have some of those features available in the predict side of things, but for the most part, this is all assuming that your data set is curated and you have done your work replacing missing values. You've done your work to make sure that the data is in the right format, those type of things. Okay? So let's close out of this. Let's go back to the data set data page, and now let's scroll down to visualize. Let's click on visualize here. And so what Driverless will do now is run a small visualization model. It'll turn on and off 20 different types of visualizations and only show you the ones that are actually have been triggered. Things like outliers, skewed histograms, correlation graphs or correlation scatter plots. This is not like Tableau. Okay, even though Leland Wilkinson, who works for us, came from Tableau, who wrote Grammar of Graphics, is actually building this piece in Driverless for us with his team. This is not a Tableau where you can generate thousands of scatter plots of every combination of your feature, your columns, and so forth, and then try to dig through everything. We actually use the machine learning in the background to dig through all of this data first, and then find visualizations that are interesting, that are something that you need to look at. So now let's go toggle on, and let's go see what those might be. Now, these visualizations will change with every data set because things may get turned on, things get turned off. Okay, so these visualizations are all going to be different, right? So certain visualizations may be turned on and may be turned off at different points. These visualizations are going to be turned on and off if certain thresholds are met. Thresholds for outliers, thresholds for missing heat maps or skewed histograms or things of that nature. So there's about 20 different ones, and they may all or may not be turned on, and they'll all be different. So for in this case, we have a missing heat map, okay? We have skewed histograms, or we have a data heat map. We have a disparate box plots. We have a correlation graph, parallel coordinates, a radar plot. We even have something called recommendations where we can actually suggest to you on what you should do to your data. Perhaps you should do a log transform of your diagnosis 1. Or in the case, a square root transformation of encounter ID. Well, a couple of these things we're definitely going to reduce here. We're definitely going to drop because some of them are actually ID forms, right? As well as, maybe a square root transformation of number of medicines and so forth. So you can definitely scroll through that. You can scroll through all these visualizations and really say, hey, we don't have any weights in here for the people. Either we'll let Driverless drop that automatically, or we can drop that ourselves, right? Things like AC1 result and so forth. So some missing values are okay. Driverless can handle some missing values by doing some sort of simple imputation and so forth. But for the most part, if you have if you have an entire column of missing values, it's going to drop it automatically because we don't know, and unless you fill it in, right? You fill it in. You've done your homework. So this is a messy data set. This is a great example. Your data set should be curated, and it should not be like this way to make Driverless run faster and to make it more accurate, right? You've done your homework. Let's take a look at correlation graph. This is a neat thing. Some of this stuff is really great interactive. You can kind of scroll over here, and you can kind of say, give me between 70 and 90. What are the correlated values here? And you can see that just neat in them as well. Of course, you can download these graphs here as well by saving them as a PNG and so forth and put them into whatever you need to do. Awesome. So having said that, this is really the first part of the video series. I want to stop here and I want to just remind everybody that a couple different things. There's more information on our docs.website. So if you were to go to just docs.h2o.ai and come down over here to our driverless user guide, you can definitely check out all the other things, like especially the visualizing the model and so forth, the experiments and all those different things. You can read about it as we're going to go into our next video. All right, with that, this is Thomas Ott for NeuralMarketTrends.com, and I hope you enjoyed this video. I would love if you were to, somewhere here on this page, hit the subscribe button so you get notified of when the next Driverless AI video comes out. And I look forward to any questions or comments that you might have. Please post them in the comment box below, and I'll respond to them as soon as I can. Thank you very much. Have a great day.